right here of a sector is basically, it's kind of like when we were doing Riemann sums and we were taking the areas of rectangles. And we, like if we had some curve, we were taking all these rectangles and adding them up. And we said as the width of these rectangles gets smaller and smaller and smaller, we're like doing the instantaneous, and that's when we integrate. Yes? It's the same concept here as here. So we're basically making those, you can't really, widths, quote unquote, or these theta values go to 0. Okay? So you're making this angle go to 0 here. Does that make sense? And you're doing all those instantaneous. Like that, okay. Okay. And that's where this equation comes from. Right here. And this is your equation that you're going to need to know to find the area in polar. Because now it's from sectors. Yes. Okay. So, yes, your A and B is like your starting, and this is your ending, and they always need to go in order. So A needs to be smaller than B. Now, a lot of times, when I do this guy, I'm going to go and I'm going to pick a different value here. Whatever. I'm just going to pick a different value where it's symmetrical, and I can multiply by 2. Okay. So. Congrats, Coach. Yeah, look, I can have support. So a lot of times I'm going to use symmetry, and I'm only going to take half. So for instance, let's say that it was this pedal, it's symmetrical, and this is my alpha, and this, sorry, that's my beta. Or no, hold on. That's my alpha, and then again I return at beta. So I could do one full loop to get all of the area. Or I could have doubled it and went from this alpha to this beta or lambda and taken half and then doubled. And that's what I like to do. I like to use the symmetry knowing that this part is the same as this part. Yeah.
Does the calculator have to be in polar mode during this, like when we're finding?
No, your variable would just end up being x, and it's going to do the same thing. Okay, so that's our equation, and again, a lot of times we're going to look for symmetry. Now, on this, a lot of times they're going to give you graphs, and then if they don't give you the graph, the whole sketching of the graph is just going to be your scratch work. It's not going to get you really any points. Now, for your quiz on Monday, the 9-4 day 2, that's about graphing, and that's going to get you full points. But when we get into this, the graphs are just going to help us. Okay? So this is just a very, very, very easy one. Everything is set up for us. They told us that they want us to go from negative pi over 6 to pi over 4. And I'm going to do 1/2 my r squared. And this is the infinity guy, so this guy's already squared. Done. There's my setup. Yes? So then we could plug this into our calculator or do it by hand. Let's just do this one by hand. We'll do the rest with calculators because this is a very, very basic one. So my 1/2 can cancel with the 2. So antiderivative of cosine is, nope, positive sign. From negative pi over 6 to pi over 4. Sine of pi over 4. Radical 2 over 2 minus sine of pi over 6. Negative 1/2. which becomes radical 2 plus 1 over 2. Okay. Let's go now to this guy. What hint did they give you in the wording of the question that this is going to be a petal? So they're telling you you have a petal. So I know that I'm going to have some kind of flower. This is sine, so I know I'm symmetrical about the y. And this is even inside, which tells me how many petals do I have? 4. Okay. Let's go find our tangents. Yes? Is anybody stuck on this part still? So all of the pi is the same line as 0, yes? Theta equals pi and theta equals 0. We can see right here. That's the same line. So I don't need to do that again. Now we could go ahead and check that these are actual tangents at the pole, but once we start graphing, we don't really need to check and everything. We can just go, okay? Because that's not a point here anymore. The only time you're ever going to have that was on the quiz today, and you've been graded on it. Now we're done. Okay? So that's just one of those things. Okay, great. We know what a tangent at the pole is. Now we just use them. We don't have to go check and all that fun stuff. Okay? Now, this is what we're getting to. Okay? All of that was just to kind of help get you to here. Okay. So now I have that guy and I have that guy. So I'm going to go make my chart. We're just going to make it as much as needed here, because we're always under the time constraint. So let's go ahead and plug in my 0. And what do I get out? 0. We knew that. That's a tangent at the pole. So there's where theta equals 0. And then, oh my gosh, if I jump to pi over 2, I'm already where? Back at 0 again. So I definitely need to find something in between there. What would be a good one to plug in? Pi over 4 is very good because when I plug it in, it's actually going to be pi over 2 because I'm multiplying by the 2. So sine of pi over 2 is 1, and then times the 6 gives me 6. So at pi over 4, 1, 2, 3, 4, 5, I'm at 6. And remember, we're sweeping, and they told us that it's a petal. So this right here gives me everything I really need to graph the rest of that. Do I really need to go and do anything other than that? Okay, so I'm going to go ahead and say, well, I know that it would go, whoops, out to here, and out to here, out to here. It looks something like that. I made that one petal a little too big, but whatever, it's just a sketch. But this gave me all the information I needed, because I just had to find the area of one petal. And even if I had to find the area of everything, I could take this one petal and multiply it by 4.
Sorry.
Yeah, I know. Okay, so thinking about the symmetry then, just on this one petal, do I see symmetry? Mm-hmm. I can see that both of those halves are the same. So I have a few ways that I could set this up to find the area of one petal. I could take 1/2 and go all the way from the 0 to the pi over 2, or yeah, pi over 2 of my r squared. That is typically something I won't do. I will probably say I'm going to go and start at the 0, stop at pi over 4, find this area, and multiply it by 2, just to get rid of that 1/2. So I could go 0 to pi over 4, again, of that r squared. Could I have also went from pi over 4 until pi over 2 and doubled that? Sure. Pi over 4 to pi over 2 would give me this red. So I could have doubled that. Jackson, you look deep in thought. Do you have a question? All right. So now you actually get to plug this into your calculator. And this is where you have to be efficient with your calculator. Oh, look how beautiful your flower is there. It's really good. So I'll tell you, I got exactly 9 pi over 2, approximately 14.137. Depending on if you're using an 89 or 84. You only squared that 2 thing. We need to square the whole thing, so you need another parenthesis somehow. Okay, so just so we know, I would not be grading right here. I am not going to be grading your graph for this question. Now, for your quiz on Monday over 9-4 day 2, I am grading your graphs, right? So as I'm grading your graphs, you guys need to make sure that as you go, you are nice and smooth. I don't want to see a point, right? I need it to be smooth. 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 Everything is nice and smooth and polar, unless it's at like some cusp on a heart or something, okay? So yeah, so make sure that it's very smooth and not jagged at those ends, okay? Okay. You guys try this one with your buddies. Before you start, talk about what you know that polar graph should be, like some things you can pull from what's given in the problem.
gonna keep going. Just to see.
How many tangents at the pole? 3. Once you and your group decide that you agree on them, I'll come check and tell you if you're right.
Yep. X. What? Six. Or like if theta equals 0. I don't know. I got 2. Oh, 2 cosine theta. Yep. Yep. That also gives you 2, I think. From 0 to pi over 6.
Is this right here all the information you would need in order to complete the rest of this graph? Yeah. Because there's half a petal, right? So it's going to go here now, and it's going to skip every other one, right? So I go here, 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 and then back. And that's, the links are a little off, but I mean, you got the idea of my fluid. So it's like, does that make sense? As it's traveling, it travels in this weird direction. So you have to be careful. But just this part right here was all I needed to complete. I knew it was odd, so there was only 3, so the petals are going to have to go in every other one. And this wants you to find the area of one petal.
So I'm just going to either go from 0 to pi over 6 to pi.
Okay, so keep going. I'm going to tell you, you should get either pi over 3 for your answer, which is approximately 1.047. Oh, I plugged in 0 and got out 2. And then I knew at pi over 6 I was at 0. And I'm going to want to see your arrows. Very good. Nice. Perfect. Right, you did. You did go. You generally have to have.
So we do this whole level part.
Yeah, so the whole pedal.
The whole pedal is part that also is in purple.
Yeah, so all of that's the pedal. So I went, for me, I thought it was easier to go from 0 to pi over 6. And then double it. So I only took half the pedal and doubled. 0 to 2 pi would go all the way. It'd find everything. Huh? Oh, you have to go backwards. Start here and go to here. Yes. Yes. Okay? Okay, so those were the easy ones. Now want me to check your tangents at the pole, I will. You should get 2 of them. And we should know that because we have an inner loop, so that's going to give us 2. Just like we knew we had 3 petals, so we're going to be finding 3. So 0, we are at 6. 1, 2, 6. And then what do you want to do next? Pi over 2? We are now at 2. And then we could go ahead. I know 2 pi over 3 is in between this guy pi, right? So 2 pi over 3 would give me 0. So then we're here. And then at pi, where are we? -2. So we're facing pi, but we are back 2. And are we seeing the flow yet? That's definitely could be better, but we get the idea. Everybody good with the graph? So now it's asked for the area of the inner loop. So this inner loop is right here. So we could start it here and end it here and not do any symmetry. We could start it here and end it here and multiply by 2. Or we could start it here, start it here and end it here and multiply it by 2. You pick. I'm gonna do the yellow. Okay. So I'm gonna double, and I'm gonna go from that 2 pi over 3 to the pi. And that would be the yellow part. That 2 pi, now it's gonna be blue. The 2 pi over 3 into the pi, and it gives me this bottom half. So that's why I'm gonna double it. No, 0 was way over here. So just because you're at the pole doesn't mean you're using 0. That's why I like to find these tangents to know where I'm at the pole, basically. I know where I'm at.
4 pi over 3. Sorry.
So then of that r squared. So you basically had 3 options you could have done for this one. And still got to the right one. See if you guys can get this. So putting it in your calculator is still a whole nother skill. So make sure you can get one of those answers. That's what we're going to do next. Well, the area between the loops is what we're going to do next. If we just wanted the outer, then I would start at here. I would start here and go to here and double it. So this guy was at 4 pi over 3 until 2 pi, right? Or we could have done, 0 to 2 pi over 3 and then doubled that. I just wanted the outer. The next one we're going to do is the difference between the two. That's what we're going to do next for the difference. So the difference, like the area outside the inner but inside the outer. That's what we're going to do next. If I just wanted the area inside all of it, then I would go from here to here and double. Okay? Okay. Anybody want more time on this one? Raise your hand. I'll wait. Just tell me. Otherwise, we're going to move on. Okay, graph the next one. Then we'll worry about the question. The pull-friendly question tends to help you graph. Yeah, I need everybody's quiz. That's what I was saying. Yeah. That's what we're going to do today. I do. It makes it so much easier so you don't just assume that the pole is 0 or assume, right? So that's part of it. 7 pi over 6. we at 0? Pi over 2. 6. None of our tangents yet have came into play, agreed? So I'm not throwing them in yet. So I'm going to keep going on to pi. 2. Now I get a tangent. Now I know I'm at 0. Then I can go on to 3 pi over 2, which actually is going to be a negative, how much? 2. So I go back 2. And now hopefully you can sketch this. That was horrible. I'm going to do that again. Still probably not fat enough, but it's a little better. Okay. Huh? Yep. So we have to do this area between the loops. And that is just this part. So we don't include that. So we're going to have to go and take the big area and then subtract out that little loop. So where does the big area start? Negative pi over 6. So it starts here at negative pi over 6 and it goes until pi over 2. Did anybody say, I'm going to start at pi over 2 and go until, what? 7 pi over 6. That would have been fine as well. Either one of those cases, we will then have to double, because both of those are half. I'm just going to put r squared since it's the only r in the problem. So that's going to be the big. Then I have to go and subtract out a small little loop. So without me saying, see if you can get the correct bounds for the small little loop. Without me saying. You have 3 options to pick from. If you did the 1/2 times the 2, you could have said from 3 pi over 2 until 11 pi over 6. You could have said You could have said 7 pi over 6 until 3 pi over 2. If you didn't double it, if you just kept the 1/2, then you would have to go from 7 pi over 6 all the way until 11 pi over 6. Those were your 3 options. Oops. Okay. I think it's because of my sleeve. This Okay, so then I wanted to go, I'm going to double the 1/2, and I'm going to go from 7 pi over 6 until 3 pi over 2 of my r squared. But again, you have the option. Whichever way you do it, you should get out, if you did it exact, 4 pi plus 12 radical 3. If you approximated, you get two different answers. 33.350 if you truncated, or 33.351 if you rounded. See how it's so much better, Grant, if we plot our theta values. So we're not saying, what was that? Where was that? Okay? And that's why if they give you the graph, you want to first go in and actually just plot what they are.
Will we be counted out on Monday if we don't have the data equals?
No. Oh, on Monday? No. So you said negative 1/2 to pi over 2. Oh, that whole thing. Did you square the whole thing? Looks like it. Okay. Minus 7 pi over 6. Pi over 2. Square the whole thing. You left out a 2.